Hey math kids, we're in section 10I and we're talking about the formal definition of independence, and I think we're just going to start right off with the problem. So we're on example 23, and this will be the only example that we do for this part. And it gives us just a few things. Okay. It wants us to, there's two parts to it though, but the first one is find P of B. So if I'm drawing we have A and B, and so I'm going to draw a Venn diagram. Call this A, call this B. Now if we want to find the probability of B, there's two pieces that we need to find. We need to find the intersection of A and B, and then we need to find the probability of the intersection of A, of B and not A. Okay, if we add both those together, we get the entire circle. So hopefully that's clear. I'm just gonna do this to make it even more clear. So that blue section is the intersection of B and not A, and then the intersection of A and B is this football section right here. And then if we add those together, we get P of B. So to find this, we're actually going to go back to what we learned on the previous video, and we're going to use conditional probability. So from the previous video, we had P of A given, P of A given B equals P of A intersect B over P of B. We're going to do just a little bit of algebra to bring this up here, and so we end up with P of A given B times P of B equals P of A intersect B. So this is what we're going to use for this part. Now, the first thing is we're given A, so we're actually going to swap all of these. So we're going to say P of B given A times P of A is equal to the red section. Okay, and so P, we're given this first thing, it's 1/3. And then P of A is 2/5. And so if we multiply those, we get 2/15 for the intersection of B and A. So in other words, this is the red portion on the Venn diagram. Okay, now if we want to do this situation, we're going to plug it in here. And so it's going to be B given A, not A, which we have that right here. So P of B given not A. And then it's going to be P of not A. Now we weren't given that, but since we know what P of A is, P of not A is just everything that's left over. So it's 2/5. So this would be 3/5, because 3/5 plus 2/5 equals 1. And so if we plug those in, it's just 1/4 times 3/5. Okay, we multiply that out, it's 3/20, and that is representing the blue part. Now we just need to add those two answers together. So we have 2/15 plus 3/20 on that. And so we need to get common denominators. We want to turn those both into 60. So this one's going to be 4/4. This one's going to be 3/3. So we end up with 8/60 and 9/60. So we add those together and we get 17/60 for P of B. Okay, so that answered the first part. Now the second part, it says, are A and B independent events? Justify your answer. Well, I have to explain this a little bit before we start it. So if P of B given A is equal to P of B given not A and equal to P of B, then we have independent events. So if we look at P of B is equal to, and I'll put a question mark because we don't know if it's equal to, P of B given A. So we come up here, these two, whoops, not that. So this one, and then the answer we just got, this one. So if those are equal to each other, so let's write those down. So this is 17/60, and P of B given A is 1/3. Those are not equal to each other, so these are not equal to each other. So these are not independent events. Or you could just say dependent. Okay, if you need additional help, please come to Math Lab. Until then, calculator.